Welcome to the Tales of Africa podcast with your host Richmond Setrana. Today I am here with a young Ghanaian man called Barnabas Nomo who has built amazing inventions with his team. So as you are well aware, we tell amazing and inspiring stories of young Africans who are doing extraordinary and amazing things. And to hear today, Barnabas is going to tell us about the kind of things that he has built with his team. They have built electric bicycles, electric wheelchairs. They have ventilators with amazing features, and he's here to tell us all about it. So, Barnabas, it's an honor to have you on the Tales of Africa podcast. You are welcome.
Thank you. Uh, Pleasure to be here.
Okay, Barnabas. So you're a young man, and people are hearing the kind of things that you've done. These are things that it's not common for young Africans to do, right? So how are you able to do this? People want to hear from you, but before then, they want to know a little bit about you, your background, who you are as a person.
Okay, cool. My name is Barnabas Nomo, obviously. I grew up in Koforidua, which is about 130 kilometers out of Accra. We go through the mountains. And I guess since my childhood, I think I had a good childhood. You know, I had a big brother who really liked computers. And so when I was growing up, actually, we had a computer in the house.
Okay.
You know, my mom, I wouldn't say my family was like very well to do, but I mean, they were able to figure out what was important for us and got us some of those things. So, I got exposed to computing very young. My early memory of a computer is like I think I was like 4 years old or 3 years old. And my brother used to do all these things where he would open the command prompt and type a bunch of funny stuff. So I loved those things. But I think when I was growing up, you know, it was really difficult to find places where they taught programming and things like this. You know, like early 2000s, you wouldn't really find anything like that. So
That's true.
you'd go in and they teach you maybe it's Beacon or like Microsoft Word, PowerPoint. So I guess I kind of gave up. But then when I got to high school, I think my first year in high school, there was a program by a New York-based company called Elite. It
Elite.
means emerging leaders in technology and engineering.
Okay.
And so it was started by this graduate of Columbia University. His name is Chelsea Roback, and I guess the goal was to come to Ghana and give kids some kind of taste of what technology really was like. So, I went to Elite in 2012. I actually wrote my first meaningful line of code, 7th August 2012.
You remember the dates?
Yeah, because
I'm sure, but you must be young then, right?
yeah, it's really
Yeah.
young. And so I really I think when I did that, I was like, oh, this is it. This is really what I wanted to do. And at that time, I guess I had to explain to my dad why I wanted to attend the programming. He's been very active in our life since we were kids. So when he's like, if he says no, actively no, right? Like,
I get
and if he says yes, actively yes.
Yeah.
So I just kept going, and over the years, I got a lot of mentorship, and you know, I got to meet people who were doing like really epic stuff, right?
Okay.
And so because of that, I think I had a chance to learn a lot of things from people like that, and that kind of sparked in me this kind of curiosity. But I think also there's this thing where I think I built a lot of competence, and it helped my confidence. So I see problems and I'm able to say, well, I can attempt to do something like this, or I do not want to do this. And so, that's really kind of how I started out generally. I have, yeah, what else? I don't know what else about me that's interesting, because I think my whole life has been around this since my childhood. So,
Okay, that's awesome. So, what would you say has been the most exciting part of the journey for you? Like, you know, you are into computer engineering, robotics, and all that. And most people also grew up around computers. But there's a general notion that for most people in this country, even in Africa, right, the general notion is, oh, you are brilliant, you like computers, but go into maybe electrical engineering, become a doctor, enter pharmacy, and that kind of thing. So why did you still decide to stay this particular course, knowing that it's not a popular choice in this part of the world?
it's a couple of things. So first of all, I guess I understand where those sentiments come from, because let's say your parents put a lot of money into you, and they're expecting that you're going into
Yeah,
a field where
exactly.
you are secure, right?
Yeah,
Like, let's say, well, they know that this field is a more secure field, right? And
yeah,
even a conversation I had with my dad, because initially there was a bit of opposition about where I wanted to study and what I wanted to do. And I think he boiled it down to me as, this field you're going into, if you need help, there's no way me or anybody I know can help you, right?
okay,
And I think that's what the main notion is. But on the other side, though, I mean, Ghana has a very procurement-driven economy.
yeah,
That means nothing is really done here. A lot of things are imported. And if you have an economy like that, a point will come up where if you do not start to innovate, you are going to just die out, right? So
yeah,
I think it's a level of risk that I personally wanted to take that, well, I
okay.
mean, I'd like to try this while I'm alive, and if it doesn't work, well, I mean, I hope it works, right?
I
Because
understand.
I don't want
Yes,
to know what
yes,
happens if it doesn't work. But that's really the main thing. But also, I think I also have a lot of people around me who were like
well,
interested in
like-minded.
things like this.
Okay,
I recently got to learn a lot about my grandfather, and like he could have been a king if he wanted, but he wanted to do craftsmanship and
okay.
build bridges and stuff like that. So I think
So I
maybe
think it runs
genetically,
in the family. Yeah, you guys you like to do
genetically,
things with your hands.
it
You like
just
to
went
build
to,
stuff.
yeah. So that's really the thing. But I mean, I also really understand how the sentiments are. But I think if you look now at um, the environment nowadays, you realize that a lot of people are more encouraged or more confident into going into these fields because
Very
it
true.
looks like, well, there's some kind of future in it,
Yeah,
right? And I mean, it's also because of, I guess, a lot of our exposure to technologies around the world and how things are going. And so, I mean, in as much as, yeah, there isn't, I mean, it's not a big field here, but what also that helps us with is, for example, if what we are doing as a company succeeds, economically, it places us in a very unique standpoint
very true.
because, like, oh, these guys have been the first to figure out how to properly do engineering and robotics at scale
Okay,
in a very resource deprived environment like Ghana, right?
okay.
And so that's, I mean, it's very difficult to figure out, but I guess I'm still, we're still on the path. So,
And
yeah,
you are doing well.
thanks.
So, and you are a recent graduate of Academic City University, and that's a very unique school. So, most people want to go to Legon Tech, they go and read linguistics, sociology, and all that. But Academic City University has distinguished itself. It offers courses like robotics and courses that are normally not offered in Ghana here. So, how has that kind of education, how has it shaped you and the career that you're trying to build for yourself?
I think in a lot of ways, I mean, maybe people who knew me before I started school might think I'm giving the school undue credit, right? Because, like I mentioned, I used to do some of these things before I even started school. But I think, regardless, coming here actually opened my mind to a lot of things, like, for example, how to properly build an engineering product,
Okay.
right? So, for example, let's say someone could sit in his garage and do something, right? And we all have done this project. But then let's ask them, if you're going to make 100, what will it take,
Okay.
right? So then you realize that, well, there's this whole movement of it's easy to make, let's say, one of a product, but then to go from one project to making an actual product that meets quality compliance
Yeah.
testing,
Mass production and all that.
standardization and all that, the processes you go through.
Yeah.
That's really, really crazy. And those are things that I guess going to a school where you have a proper engineering like training really, really assists you with, because I mean, I was here, aside that to being a very, very organized person,
Okay.
I think it's something that doesn't get talked about as much in engineering, like keeping a structure, keeping things very organized, and it's something that you learn in school, right? And the way we learn those things here, it's not like there's a course in structure or organization, but I can show you our timetable. From first year, you're packed, right?
Yeah.
So you're doing like 8:30 to 5:30 every day. And for some courses, even a math course I took, you had to do a project in mathematics. And so what my group did, we had to simulate the solar system, right?
Wow.
And like that's how I even got this computer, because the early
Wow.
computer we had actually crashed, like
Okay.
stopped working when we finished our math project, and so you have to squeeze in things like that, and it teaches you, well, how do I prioritize? How do I start to put some structure? Because I mean, you want to pass the class,
Yeah.
right? Yeah, and I was also on scholarship, so I can't lose my scholarship else.
Wow.
I can't pay,
Okay.
right? So you
I'm
just,
sure the school fees must be crazy.
yeah, I mean, it is. But
Yeah.
I think what happens here, though, we have what we call the presidential scholarship.
Okay.
And if you can prove beyond reasonable doubt that you are somebody who merits receiving a presidential scholarship, yeah, you're going to get it. And
Wow.
I mean, it has its conditions, right? For
Yeah.
example, where you have to do some, I guess you have to be like a shining example for people. Also, you need to maintain some specific grade points, right? So, I mean, you've seen
Okay.
some of these projects. I built them while I was in school, and
Wow.
so the thing is that you start to realize, and it was something I didn't really understand it very well until I started talking to my friends in other schools. And I mean, they'll tell me about how rigorous their classes are and how swamped they are. Just ask like how what you've been up to, and they tell me, and I compare it to what I'm doing. It's like first year for our lab, we had to build this wireless charging device, like inductive coupling. We build a laser-based fire detection system, right? All as a first-year student, like you do things like measure things without putting rulers on them, and
Okay.
you have to go read about how people used to do them in ancient times, and I'm like,
Okay.
well, that's a lot of rigor. So
Wow.
there's some crazy training that I guess it's not very enjoyable when you are going through it, but like if you look behind back, it's cool. I complained a lot when I was a student, but yeah, I don't
Oh,
know.
it's fine. I'm sure people understand. Brilliant minds are sometimes very difficult to understand. So, last question before you take us through the inventions that you built together with your team. So, you put together a team of young people, or a team of young people came together, and then you formed Goliath Robotics,
Yeah.
and you have some amazing inventions that have even gone viral, right? So, can you tell us a little bit about that? How did that happen? How did you guys sit down and decide that okay, let's do something, and why the kind of products that you went into, like electric bike ventilators? Why did you choose those particular products?
Okay. So I mean, there's one very unique thing about Academic City that I didn't mention earlier. It's our president, right, Dr.
Okay.
Fred. So he had a very impressive career in corporate America, vice president for Siemens Healthcare and all that. I mean, he's done like over 52 inventions,
Wow.
23 plus patents, right? And I mean, he moved to Ghana and wants to do education properly, right? And so he has this thing called innovate or die, right? And
Okay. Innovate or die.
yeah, and
Okay.
he just pushes people to try and do stuff like meaningful stuff with your time, try a bunch of things, build localized solutions, really. And
Okay.
so initially, like he actually started the ventilator. It was during COVID, and I guess I had to play a critical role on the project. And I mean, he's someone who would go to whatever extent to ensure that his students are positioned well and are going to succeed, right? So,
Yeah.
like for example, during COVID, when everyone was on lockdown, he was able to get a government permit
Wow.
so that a car can move from here and pick me up in Koforidua and bring me back, right? Like, so
Yeah,
you
I had
have
to get a
people.
government permit just for you.
Exactly, right.
Wow.
You get me?
Yeah, I get
Somebody
you.
like that.
Yeah.
And so I
Okay.
think we've had this conversation before. And I mean, he's really into more localized solutions. Like, I mean, and even the curriculum here, you do technology and society. It's more like, well, I mean, yeah, there's blockchain, there's all these, but how do you make sure you're building stuff that impacts the people in your community, right? And
Yeah.
so the whole philosophy of Goliath robotics, it's derived from the story of David and Goliath, where it's like David, if you look at it at face value, let's say you detach all sort of spirituality from it, it's just David saw a giant. He
Okay.
went to the riverbed,
Yes.
got some stones,
Yeah.
and beat Goliath with it,
Very true.
right? And so stones were like localized, right?
Yeah.
That's a localized solution to beating a giant in armor.
Okay.
So our main thing is, well, anything we encounter, I guess the question is, what stones can we use to beat this, right?
Okay.
And so our main philosophy really says we just want to make a lot of technology as affordable as possible, right? So that the average Ghanaian really
Okay.
is our target market can
Okay.
afford. Because I
Okay.
mean, you see a lot of companies coming into Ghana to do stuff, but you can tell that whatever they're doing,
There's a mismatch
yeah,
between what they
because
are building and what the people need. It's not
yeah,
contextualized.
yeah, I mean, there's a small fraction of people who would
Yeah.
benefit from that,
Very true.
but like to pick, oh, a Ghanaian at random, can they afford our technology? You know,
Okay.
so I'll give you an example. So like our very first product was an electric wheelchair.
Okay.
As Goliath Robotics, the ventilator is, I mean, an academic city project. I worked
Okay.
on it while I was on campus, and
Okay.
but with Goliath, the way the wheelchair came about, you know, my co-founder is Andrula, mechanical engineer,
Okay.
designs almost all of our products. Even I guess every project I've worked on, she's been like the person designing. But
Wow.
she lived with her grandmother. Her grandmother was a very active woman, and then one day she had a stroke. And I mean, Angela was really young, so how does she take care of an older woman who has a stroke? Like, I mean, she's going to be much heavier.
Yeah.
Moving her around in a wheelchair, it's going to be a lot. And also, there's this whole psychological toll that it will have on the grandma, because, like, she's a person who never depended on anyone, and now she has to depend on her grandkid
Okay.
to do basic things. And I mean, so, and the question is, like, we have a lot of technology in abundance today, but people living with disabilities still struggle to access things like doors, passages, you know, staircases, right? Like, there's so many barriers to people with disabilities that, like, it requires significant social intervention in order to make life easier for them, right? So I mean, there are wheelchairs, for example, and the wheelchairs you see, even the very expensive ones, you can't use them in Ghana
Yeah.
because the roads are just terrible. I mean, you can use them in your house, but if you go outside of your house, then you could get stuck in a pothole and never come out, right? So, and I mean, the main reason is that for example, the assistive technologies market is very tailored towards like high income like markets. So people in low income areas are not really able to afford them. And the way they afford or they get them, usually there's these charities and other intervention programs. And those are more focused on procuring things at volumes instead of at quality and things like that. So, I mean, the question became, what can we do about this to make life very simple, right? And so it was more like a school project that we used to do.
Okay.
And when we work on a project, so let's say while we are working on an active project, it could get very tiring and people get drained. So we pick a side project that we can do in a short while.
Okay.
And you know, when you keep achieving, if you set goals and you achieve them, you get this whole adrenaline boost. You feel
Very true.
good, and you use that energy to
Yeah.
jump back on the main thing you're doing. So while we were working on the electric wheelchair, you know, over the summer, one of my teammates, Patrick, he was like, well, I mean, we were having this whole talk about bikes. So we decided to try and electrify an already existing bike. So we met a guy who had crashed this bike, brought the frame in, straightened it, you know, cleaned it up, and we just did a simple test where
Okay.
we put some electric motors on it and had it working, right? So I guess the idea came from there. And I mean, we started also doing some research about e-bikes and stuff, and we realized, well, if we wanted to make electric bikes affordable, there is a couple of things that we would have to do. And so I think that's when the real vision of the company started to come into sight, because we realized, well, we use similar motors on the wheelchairs and similar motors on the bike, but then instead of having a bunch of random technologies, can we develop a central technology that can run all of these things? And the only thing that needs to change is the firmware or the software that we upload onto the controllers. And so currently, yeah, we have something called the unified controller. It's just a fancy term for, like, because it runs all of our products. And I think that's the general idea that we'll be using for everything, you know. And so I guess that's really where the company came from. We have a bunch of other projects that are more in R&D, not yet products, because we need to figure out. I mean, that's, and again, more on why engineering projects sometimes take a long time, because there's a lot more adherence and compliance that you have to kind of hold your things to. So I know this is a very long answer, but
Yeah, but we need to understand it. So thank you so much for that. And I think it's time for our viewers to see the inventions, for you to demonstrate how they work, for them to have a feel of what it is, and also be proud that at least there are young people like them who are actually doing wonderful things. So that will spur them on to also do great things. So thank you
yeah,
so much.
sure,
So
no
stay
problem.
tuned. Barnabas is going to show us how the ventilator works, how the electric bike works, and then we can all take a look at it. Yeah, welcome back, our viewers. We are here with Barnabas. He's going to show us the ventilator that he worked on whilst he was here with his team. So, Barnabas, take us through it. What is it that we are seeing here? Like, how exactly does it work?
Okay, so this is, I mean, these are ventilators. So I think during COVID, their importance became very, very uh, abundant, I guess, clear to everyone. But
Okay.
basically, a ventilator helps people breathe, right? So there are different types of ventilators, and we have negative pressure, and then we have positive pressure ventilators. I guess negative pressure ventilation is how your human body works, right? Your diaphragm relax, like goes down to draw air, like causes your lungs to expand, draw air in, and when it contracts, the air is pushed out, right?
Yeah.
But those machines are really bulky. You don't get a lot of movement or free range. So, um, positive airway pressure ventilation, like which is this type, really it's about can we create some kind of pressure in your air lungs, in
Okay.
your lungs, so that when you breathe, like your larynx is always open and air can go in and out. And so that was the very first model. It was more like a respirator.
Okay.
And so all it does is when it's on, it just pumps air,
Okay.
right? Not regulated. And the goal is that if you're providing excess, it goes around the sides, right? But then you're maybe trying to do some very precise work. For example, if it's a tube going down the person's lungs, then it becomes a bit more tricky because if you provide too much air, your lungs are like a balloon, really.
Yeah.
And if you blow too much air in a balloon, it pops,
Yeah.
right? So you don't want to drown a person with air, more or less, right? Like, because that would be very fatal. And so you start to put in a bunch of sensors and start to optimize the controls. And so that was version one.
Okay.
This
This
was,
one,
yeah,
version one.
version one.
Okay.
This was version two.
This version two.
Yeah, and then
Okay.
like this is currently
This is the
version
current
three.
version.
Yeah,
Wow.
and that's what's undergoing clinical trials. I mean, they had a couple of comments
Okay.
about the current status, but I mean
Okay.
we're working on
So,
them. So
so you built them during the COVID period
yeah,
when
so
when they became a necessity, right?
yeah,
Okay.
so yeah, at that time,
So
that's
that's
when
like how many? 3 years ago.
3 years ago.
Okay.
Yeah.
Okay.
So when I mentioned that Dr. Fred got a government permit,
Yes.
so that
Yes.
yeah,
Okay.
it
Okay.
was
So
to
this
come
was
work
what
on
it was about.
this. So he put up a team, and
Okay.
I mean, we kind of
Okay.
under his leadership did all of this.
Okay. So it's not operational yet. Oh.
Oh, I mean, I could show you.
Okay. Show us. Sorry.
Yeah, these ones. I mean, this is the current flagship version, so
Okay.
that's what we use to show to people. But then you notice there are knobs and buttons here.
Yeah. But
There are
this
none
one
of
doesn't
those
have
here.
it.
Yeah,
Okay.
because this is more like a touch screen.
Okay.
So I could show you a simple demo, right? And yeah, so let's say, yeah, let's do 8
Okay.
8 breaths per minute,
Okay.
and I set this to 1:2, and I can hit start. Right. So then we kind of have graphs to show,
Okay.
and
Okay. So it's like it's beginning to fill up with air.
yeah. So I mean, this is more like ideally your lungs would have had
So-
some
so-
air within,
Yes.
and so when you breathe back. So I mean, for now it's kind of inflating up to that point, but
Okay. Don't know if the camera, if our viewers can see it. Yes. Wow. Okay.
all right. So just so it feels
Okay.
all right, and so the sound you hear is really just the valves opening and closing. So it's
Okay.
like you're kind of whistling, I guess.
Okay.
And so this here is an expiratory valve.
Okay.
And so depending on who you are working with, let's say
Okay.
if it's a grown-up, there's
Okay.
a kind of pressure you want to maintain in their lungs. So you
Okay.
can just set that here.
So,
And when the pressure in the system exceeds, it will escape from here so that
okay.
the lungs don't take
Okay.
damage.
So I want you to, explain it in layman's terms.
Yeah.
The person doesn't understand what's going on. How can you explain it? Does this go into the mouth of the elderly person? How
No,
does it work?
this part is outside. So ideally, this
So
is
this the person's lungs. Oh,
yeah. So a
okay.
simulation. So this could have been a mask or a tube.
A tube
Or-
inside the
yeah.
person. Okay, so
Or a
it
mask,
goes
yeah.
inside
Yeah.
and it's connected to the lungs. So you pump the air directly into the person's lungs. So
Yes.
that's
Or
it.
it could also go on your face like a
Okay.
mask.
Depending
And
on the person's breathing difficulty.
yeah.
Okay, I get it.
That's generally it. So
Oh, wow.
this is to exit. This is
Okay.
kind of to prevent air from going backwards into
Okay.
the system, right?
Okay.
So every few cycles you have to change these. And,
Okay.
yeah, and I think our main goal now is to make sure that we want to display how much oxygen is in the system. So
Okay.
I was actually working on it
Wow.
this week, so that you know exactly if the doctor looks at it, they
Yeah.
could tell if you're getting like enough oxygen for the patient or it's just air they are breathing.
Okay.
And you know, also making sure that the bag down here can be replaced easily. Right.
Okay.
Currently, the setup we had didn't allow for that, but
Okay.
it's also something we're
It
working
gets
on.
better with time.
Oh yeah,
Okay. So
definitely.
is it something? Is it for home use? Is it for hospitals?
Right,
What's
for
what's the ideal plan for the ventilator
Ideally, it's for hospitals.
It's for
I mean,
hospitals.
we can't sell a medical product to
to an
an
individual?
individual.
Okay.
I guess this is something that if the operator doesn't know what they're doing, they could cause themselves serious harm.
Okay.
Right? Like if you have a blood pressure monitor, it doesn't really do much to harm you, or a diabetes checker. But for something like this, yeah, you
Okay.
deal serious damage to
And
yourself.
I remember during the COVID time, there were news that Ghana doesn't have enough ventilators. We had to try and see if we can import some ventilators and all that. So I think this would have really come in handy.
Oh yeah.
So, so what's the plan? Do you have timelines on when this can be produced on a mass scale?
I think that part, you know, I would have to kind of
Okay.
find out from Dr. Fred. I'm just there. I mean, but also it really depends on how our clinical trials go, right? I mean, I mentioned they have a bunch of comments that we're working on. More about, I think, the amount of air we deliver per breath.
Wow.
They want it to be higher, at least twice the minimum requirement, so that even if there's some failure in the system, you know. So, I mean, those are things that if we do figure out, and I mean, whatever the doctors say, then we would go ahead. But generally, a lot of medical devices take a long time to hit the market. You see, for example, if we had done this around COVID, probably the process they would have to go through wouldn't be as severe, but like right now, because back then, emergencies, ventilators, they would have just fallen under that easily. But now, like, it still has to go through the
go through a
proper
more thorough
method.
process.
Yeah.
Okay.
And I mean, it's one thing to do something, but if you want to do it right, and you know, you don't want to be getting lawsuits first month of release, because that would be very bad. Like, you release a product and people are dying right away.
So this is locally produced, locally manufactured.
every
So
part
we
of
assume that it's going to be cheaper for hospitals to procure.
Oh yeah.
As compared to if they were importing it, right? Okay, I think that's really awesome and good news, and it should be welcome. And I think you should get some funding for this. Or what do you think?
Oh, yeah, definitely.
Yeah, the government should be able to sponsor such products because they are going to be used, and yes, it's locally made. So I can see something. Please, camera. There's something going up and down. Can you tell us a little bit about
Oh yeah,
that?
so this is it's more like we were creating some kind of piston action.
Okay.
So there's a bag down there. I mean, this is just a test bag, so it has a bunch of stuff on it, but basically it compresses that bag, and then the bag like lets air throughout the system. So that's really so all our controls is really making sure you're moving this in such a way that your air delivery is on point, right? And so there's a big circuit board here with a bunch of sensors, and that's what the sensors really do, just looking in.
This is amazing. This is amazing. I must commend you and your team for working on such a massive project. And we can't wait for it to be produced on a large scale for it to benefit people and save a lot of lives. So thank you so much. So at this point, I'm sure our viewers have really enjoyed your demonstration. It has been so enlightening. And I'm sure that they can't wait to also see what you have for us next, which is the electric bike.
All right, cool. So we can end this, right? All right, cool.
Our viewers, you're welcome back. We are still here with Barnabas. He's going to take us through how he builds this electric bike with his team. So Barnabas, please take us through this.
All right. So yeah, this is, when I talked about the bike initially, I did mention that we took an existing frame and
Yeah.
adapted it. So I mean, after that, I guess in terms of going into a product, we figured out, can we make our own frames locally? I
Okay.
mean, and so if you look there, actually, we have a bunch of pipes that are like have been
The
cut
pipes,
and,
the
yeah,
pipes
over
that are
there.
cut over there.
Yeah,
Okay.
you see. So they've been made into bikes. Some parts are getting
Okay.
heat treated so that
Okay.
they get hard.
Okay.
But basically, this whole frame was made in house. The only parts we didn't make was this. I mean, for example, the tires and pedals. I mean, you can just buy them anywhere. So
Yeah.
we didn't have to make all of those. But
Okay.
generally, I mean, that's our main bike. We have our own custom controller that runs these bikes, and so, for example, we have some features that, I mean, what you wouldn't find on other bikes. For example, we have cruise control, and that's what
Okay.
you use today because
Okay.
we're on campus,
Yeah.
and for testing we try not to. I mean, we are required to keep it
On the
below
low.
a certain
Yeah.
speed. So with cruise control, you don't even need to use the throttle. So
Okay.
sometimes I actually remove the throttle so that you'd actually see it
Yeah.
that it's moving without being
Yeah.
throttled. So it's one of
Wow.
those cool features with you in a couple of. I mean, after release, I mean, we have plans to be making system updates constantly. So we have an update coming out actually for
Okay.
ambient light control, where
Wow.
you wouldn't have to actually, if you're riding at night, you
So
wouldn't
come on
need,
automatically.
yeah, and we'll regulate the brightness
Okay.
depending on how bright your environment is.
Okay.
Currently, I mean, this is our battery pack, but
This is the battery pack.
yeah, and we are actually making it out of fiberglass now.
Fiberglass. Okay. Why fiberglass?
I guess it's that way we can make it into any shape we want. And
Okay.
metal forming is actually very expensive in Ghana
Okay.
because you don't get proper molds and stuff. So that's the direction we
Okay.
went in. So,
So-
those are really the main.
Okay. So can you tell us how is it powered electrically?
So we have lithium ion batteries.
Lithium ion batteries.
Yeah,
Okay.
in the bike, and then we
Okay.
have so that's what there's a charging slot on the back side.
Okay.
So you plug in your charger,
Okay.
charges for a while, you can ride it, and then
All right. Amazing. So I think it's time for me to try the bike.
yeah, sure,
So
I can.
I think it's time for me to try the bicycle. So I'll ride it without pedaling, right?
Yeah.
I don't have to pedal.
Yeah.
It will power me electrically.
Yeah.
So that our viewers can see how the electric bike works. So before then, what's the idea? Why electric bike? Why would you decide to go into this?
I mean, I'm really pretty much a bike guy.
Okay.
So, for example, we set up a biking culture
Okay.
on campus here,
Okay.
right? And so it's just things that, like, I have over the years grown very fond of bikes, and I mean, I interact with a lot of people who ride as well. And so I guess, for example, one of my friends used to go to work around airport, right?
Okay.
And he used to bike there,
Okay.
and so we gave him this. He gets there, he doesn't sweat, like,
Okay.
because I mean, if you're trying to encourage people to ride more bikes, I guess there's a couple of things that inconveniences that bicycles present that you'd also have to address. I mean, generally with mobility, yeah, you get to places faster, but also you don't really need to sweat too much if you want to get somewhere. If you are carrying loads and you want, like, your legs to be a bit free, you could use an
Okay.
electric bike.
So-
But then also, I mean, people ride bikes for exercise, and also, like, that's why we maintain the paddles
Okay.
and things like that. But
So-
it really started out more like a fun project, and became
Okay. So last question.
Yeah.
So what's the speed on this baby?
without limits. Then you can get like 42 kilometers per hour.
42 kilometers per
Yeah.
hour.
But I know
Wow.
about 45 kilometers per hour. There's this whole paperwork you had to go through, so we just
We
did
wanted to avoid the
42.
paperwork.
Yeah.
So we
Like,
limited to 42.
yeah,
I see.
it's just, I mean, you get your product onto market early, and then you're
Okay.
able to.
So the idea is, I think I read somewhere, you said the idea is to create some biking culture on campus.
Yeah.
Is that it? And
So the
not
frames
just
I
on
showed
campus.
you,
The
actually,
frames you showed me, okay.
are going to be for students.
They are
like
going
the
to be for
bikes, yeah.
students. Okay. So that students who have this bicycle culture going on, people who have bikes and they can be able to move around freely with it.
Yeah.
But you also have plans of maybe mass scaling it for the average Ghanaian to also be able
Oh
to
yeah,
afford.
that's really the plan. But
That's
I
really the
guess
plan.
the
Okay.
reason why we're starting on campus also, you have a small subset. If there are problems, you catch them early. They come to you instead of going to Twitter, things like that. So
You don't want to be
uh,
dragged
I
on
get,
Twitter.
I mean,
Okay.
but not necessarily
I
the
get it.
drag,
I
but
get
yeah,
it. Yeah, I get it.
it's
Of
stuff
course, it's
that
easier to manage. Like yes, when it's
yeah.
within.
And people here, I guess, because of the kind of education you get, you really understand product life cycles, so they'll be more susceptible to return bikes and point out exactly where the flaws are. So
Okay.
in a way, to help you refine your product. I mean,
Yes.
even with this, sometimes we ask people to beat it up, as in ride it through very harsh terrains, crash it, tell us, like if you notice the right brake.
Yeah.
Yeah, because I had a very terrible crash, but I mean, the frames were cool. The paint job suffered a bit, but I mean, so yeah, we do
I get
like
it.
those
Okay.
testing with our subset, and then we can ideally around September you should have made about 100 and have them circulating. But
Okay.
currently we're working on getting 25 out. So those are.
Thank you so much, Barnabas. So I think it's time for us to try the bike. Let's go. Okay, so before I ride, Barnabas is going to show us exactly how the bike works before I sit on it because we want to avoid stories that touch. So, yeah, Barnabas, please show us how the bike works.
Yeah. So
So you said there are modes, right? Okay,
yeah.
how does it work?
So I mean, this is cruise control. So
Okay,
currently, if I hit the plus,
okay. So
this
that's what
slowed
mode
down.
one.
Yeah.
Okay,
Two,
mode two,
three,
mode three,
4.
mode four, mode
All
five.
right.
So it's
So
going faster.
yeah.
Wow, wow.
And then so when you hit the brakes, I mean,
It's does it restart?
no, it
It
just
maintains that speed.
it cuts power. If you
It
hit
cuts
the
power.
brakes, it
Okay.
cuts power to the motors. Then
Okay.
the main brakes work. So
To
we have
apply.
like
Okay.
electronic braking and
Okay.
mechanical braking, right?
Okay.
So the thing though, like if you're riding on campus, you just try and stay in,
Yeah.
and
Okay.
and that's really it. So when you stop, you hold this because if you leave it, it's going to stamp because you're in cruise control.
It's
Really,
going to start moving.
yeah.
Okay.
I mean, we want to.
Okay.
So yeah, that's really the main feature. There's been talk of putting some kind of load sensors in the seat so that I know when you're on the bar. I don't think that. I just think people could be able to.
So let me
Press
try
this.
the bike out.
Sure,
Our viewers can also give their best.
sure. So you can sit.
Wish me luck. So I'm sure you saw how I had a feel of electric bike. It's awesome, it's amazing, the speed is incredible. So I want to know, Barnabas, when do you think this can be ready for people to also want to buy? Because I'm
Ah,
sure a lot of people want to buy cars, they may not be able to buy cars. I'm telling you, the speed on the electric bike is similar to the speed on a car. So people probably will want to afford or want to buy it in place of a car. So when do you think this can be ready?
so I guess our test models, not our test, but the small group I mentioned,
Yeah.
end of June, we roll them out. But I think generally by September, we should have gone through all the processes we need to. So we need to start selling to Ghanaians. Also, there's like DVLA and things we are going to work on this summer. So, yeah.
So any last words? Any last words to our viewers, people who are inspired, who are amazed by the thing that you've done together with your team? Do you have any last words for people who also probably also want to take your steps, enter robotics, machine learning, computer engineering, but is everything is they don't know where to start from. So
Yeah.
what kind of words do you have for such people?
I mean, I guess if you are capable of taking the risk, I mean, I would say people should go into this a lot because, I mean, currently there's more support for initiatives like this than there has ever been in our history, and so it's interesting. But I think generally for a lot of young people, a lot of the change that we want to see would have to come from us, and so these are things. If we do not take the future of our country into our own hands and try to innovate this, then we are just going to perish into oblivion. So
Wow.
that's
And it goes on at your studio here. You can see people people are really working here. The workshop here is always alive and active. And would you encourage people to probably come to academic city universities? Because it seems you guys have all the resources available for people who want to be in this particular field.
Oh yeah, I think definitely you should come to Academic City. It's probably the best place on earth. But on a more serious note, yeah, I should think so. I mean, if you notice when you came here, you've seen very few teachers in the workshop, and it's a lot of students. And that's really how things are here. It's very student driven, and I guess there's a level of responsibility you need to show. But aside that, you're free to do what you want. I mean, yeah. And I guess, Academic City really started out as a very big experiment. And part of the experiment is to give students the power or the chance to be responsible, right? You go to some schools and there are all these labs more expensive than our labs, but then it's like people are locked out of it and you can't access it. And I think over here the approach is different. That, well, let's give these guys a chance to be responsible and let them prove to us that they are responsible. And so, I mean, if you prove that you are irresponsible, then that gets taken away from you. But I think it's a very important position that we put in. I mean, my co-founder Angela used to run this place when we were students, and it just shows this is also the most expensive building on campus and in the hands of students. So I guess that being here kind of gives you a peek into the kind of things. We have technicians who are willing to help, and I think this is a problem that we run into a lot. That, for example, I do not weld. It's not something I think I would even ever learn, but I guess I understand if welding needs to be done, how it has to be done, and I think the role engineers play is quite different from technicians. So they are very supportive technicians. You can see Farouk working, takes dimensions, and that's the implementation, right? And so it really teaches you how to communicate your designs properly to somebody, and I think it's something that is very unique about this school. The fact that students, I wouldn't say as they please because that sounds wrong, but that's really what. Yeah, yeah. And I guess for any place to become very innovative or go to the next level, you have to start putting young people in places where they are allowed to succeed, but then also they are held responsible for the actions they take. So.
Okay, so to our viewers, I'm sure you've enjoyed this segment. I'm sure you've learned a lot and you're also inspired. So I don't want you to go away, subscribe to Tales of Africa, put on the notification button so that you don't miss out on all the content that we create.